Alright, welcome, hello, getting started here. You can tell there's a swim practice going on because they're super loud, because why not? Anyways, let's look at a projectile motion. We're going to study some quadratic applications. The idea is here that we want to utilize motion formulas to interpret objects in motion. What does that mean? Well, let's find out. First off, you need to know these formulas. There's one for if it's meters, and another one if it's gravity. Now, if it's feet. These are motion problems that are based on gravity here on Earth, and beyond, like these numbers here would be different. Like let's say on the moon or on Mars, because trust me, I've done a lab on that. Anyways, you're going to basically be putting numbers here or here, and this numbers at the beginning, the negative 4.9 or the negative 16, they will never change. They will always be there. That is the effect of gravity here on Earth. Okay, so you need to know the initial velocity, you need to know the initial height when you send off something. So let's look at an example, and again, notice that if it's in meters, you're using the top one, and if it's in feet, you're using the second one. So you got to know which one, based on the problem that you're reading, which formula you're going to use. So here's an example. The tennis ball at an initial height of 1.5 meters is hit upwards with an initial velocity of 25 meters per second. Okay, so which formula am I going to be using? Well, I can see here I've got meters. So I need to identify, first off, which one is my initial velocity. The VO, initial velocity, is 25. And what's my initial height? And it says it's 1.5 meters off the ground. Okay, and I will use the formula that has the negative 4.9 in the front. Now, h of t means height after time. And I'll show you what that is in a second. ht squared plus 25t plus 1.5. So this is my formula. Now, if you type this in the calculator, you would change the t's to x's. But basically, this is telling you where everything is located after a certain amount of time. So, to be honest, what I would do is I would type this into the calculator, and I'll show you all how to do that, but I would type this into the calculator on a graphing page and then press Control T to come up with a table and fill in the blanks and whatever else. But, like I could say, okay, what's the height after 3 seconds? Okay, if it's still even in the air. So then you could plug 3 and put 3 in place of all of those. Squared plus 25 times 3 plus 1.5 and see where you end up. If you were to type this into the calculator as is, you would get an answer of 32.4. Or at least that's the answer I got. So what that means is that at 3 seconds, this object is still 32.4 meters up in the air. Okay, so it still hasn't even hit the ground, because all of these graphs are going to go up and down like that. And I'll show you a graph of that in a minute. So what can we do from there? Let's look at this. So here's a picture of me having graphed it on my calculator, and you can see you really can't see anything. So what I do from there is I press menu, and then I would press window number 4, the window zoom option. And I would choose option number 1, which is Windows Settings. When you choose Windows Settings, oh good grief, let's try that again. Windows Settings, you're going to see something about Xmin, Xmax, Ymin, Ymax, like Xmin, Xmax, Ymin, Ymax. And really, to be honest, you don't need to change any of them, but I'm going to be able to write Ymax in a second here. Except probably the Ymax. Like, go ahead and leave this one negative 10, 10. That's fine. You can see here, you can still see everything you need to see up to here. But what I need to see is what's up there. Where's the max out? So I'll leave that, and it probably says something like negative 6.67 here, and change the Y max to something that fits. It's really hard to go up super high, so let's just say I change it to 100. Okay, I changed it to 100, and this is what I end up with. So I end up with this picture right here that I'm kind of zooming in on. And so you can see there, that picture right there, that covers everything. I can now see this height here and everything. Now this is not how the tennis ball traveled, but this is an image of time, and I can see that like it was going up and then it was going down. And you can kind of see here, like if you look at the little ones here, assuming that's going by ones, 1, 2, 3, 3 is right about here. Okay, so it just got past its halfway point. Now, if you press Control T, you end up with this image. You'll see the table next to the graph. So now I can go, okay, like if you look at this, and it's just giving me whole numbers, but I can move up and down, and I can say, okay, at the beginning it was at 1.5 height. Then after 1 second, it was 21.6 meters high. 2 seconds, it was 31.9 meters high. 3 seconds, it was 32.4. 4 seconds. So now I know it's going down for sure. Again, if I press menu, I should make sure you're back on this part, the graph. So press Control Tab. So I'm back on here, and then I press menu, and let's say I do a trace, menu 5-1 to do a graph trace. I can move along, and at some point I'll find out the vertex, and it'll tell me like here, the max right here, this point right here, the max is at 2.55, 33.4. Now the cool thing about that is this. First off, that represents the halfway point, and it took that long. It took 1.55 seconds, or actually 2.55 seconds to get to the max point. If you double that, that should be when it gets to like almost close to the ground. But I'll find the other 0 in a minute. Okay, so that one right there means 2.55. That's the height. So at 2.55 seconds, it reaches max height of 33.4 meters. Okay, so that's the max height. So if you fill in a table, and let's fill in a table real quick. So let's think about this. Okay, so again, if you're on the graph itself, you can always do a trace and find out like when it hits 0, and I'm going to find out in a second. The 0 was at 5.16, so you can kind of see. What does that mean? It means that at 5.16 seconds, it's at 0 meters, which means it hit the ground. That's when it hits the ground. So this thing is up in the air for just over 5 seconds. The tennis ball is what it was. Okay. So each one of these numbers here on the top row, they're telling me how many seconds. Each one of these is telling me where is the ball in height, how high up over the ground or above the ground. What does this mean? Well, that means at 6 seconds, I'm somehow negative 24.9 meters, which means I'm technically below the ground. So that's not even possible. In the real world, this answer wouldn't be possible unless you're somehow hitting the tennis ball into a hole. Okay? And a very deep hole at that, because I'm sorry, that's 24.9 meters below the ground. That's a lot. That's like 3 stories below the ground. Anyways, so you kind of get the idea. And basically, this is nothing that should be that difficult. But I want y'all to be able to interpret results and kind of go from there. Now, we will look at some that might have them already set up in vertex form, and we'll discuss that in class. But this is an introduction so that we can kind of go over this in class, and we'll probably do one of these papers in class together, and then I'll let y'all do your own. Anyways, that's it for today. Hopefully that's a good introduction for y'all. Y'all take care. Thank y'all so much for your time.